Hello everyone, welcome to the world of communication principle. So in this video, we will give you some basic knowledge on how to tackle game mission 4. So without further ado, let me introduce my team members, Modulation, Liu Qiyu, and me as the leader, Yunzhen, and also Jelena. So let us start from the basic. What is data transmission? Data transmission is the process of sending digital or analog data over a communication medium from one device to another. So the most common example of data transmission is the internet. It involves sending and receiving data over a network. So let me teach you on how to differentiate between analog and digital data. As you can see in the figure, the analog is a continuous signal that varies smoothly over the time, while the digital only uses 0 and 1 to represent the data. We can change the data from analog to digital and vice versa. For example, the higher peak of the analog is represented by 1 in digital signal.
So what are the purposes of amplitude modulation? Firstly is the long-distance transmission. AM allows signals to be transmitted over long distances. Secondly is the simplicity of implementation. It requires less complex circuitry compared to the other modulation techniques, making it cost-effective. Thirdly is the signal integrity. AM can effectively carry both audio and video signals, making it versatile for various types of content transmission. Lastly is the efficient use of bandwidth. It allows multiple signals to be transmitted within the same frequency range. And here is the process of amplitude modulation. So firstly is the input of message signal, which has a low frequency, for example, an audio, and the amplitude changes according to the information content. And another input is the carrier signal. It has a higher frequency, which carries the information over long distances, and the amplitude remains steady and unchanged. So these two signals are input for the modulator, and the signals are modulated. So the modulator signals has a mixed frequency, combining the carrier frequency and also the message signal. And the amplitude varies in accordance with the message signal, creating an envelope that matches the shape of the original message signal. And this is the amplitude demodulation, which is the inverse of modulation. So the modulator signal will be an input into the demodulator, which containing the rectification and filtering, and it will produce the demodulated signal. So in the demodulator, it has the rectification, which converts the AC signal into a pulsating DC signal, and filtering, which smooths the pulsating DC signal to extract the original message signal.
So next, I will explain about angle modulation. Angle modulation is divided into two parts. The first one is frequency modulation. Frequency modulation is the process where the frequency of the carrier signal changes according to the modulating signal. The second one is phase modulation. Phase modulation means the phase of the carrier wave changes depending on the amplitude of the modulating signal. Okay, so let's see the diagram. The first signal is the modulating signal, which is also known as the message signal. The FM signal increases the frequency when the modulating signal reaches its peak. On the other hand, PM signal increases its frequency or change the phase when there is a starting of the wave. So next, we will come to the application part. For FM, it is more immune to noise. It is widely used in FM radio and also to transmit television sound. On the other hand, phase modulation is more susceptible to noise. It is suitable for radio wave and digital transmission. It also supports an ample range of wireless technologies. So next, we will come to the application part. For FM,
Hi, I'm Liu Qiyu, and now I will explain about the radio digital modulation. So there are three techniques in this topic, which is amplitude shift keying, ASK, frequency shift keying, FSK, and phase shift keying, PSK. So this is the figure that explains about these three digital modulation. Okay, before we move on further to discuss this topic, we need to know what is baud rate. What is baud rate? The total number of signal units transmitted in 1 second, and bit rate, the total binary digits transmitted in 1 unit time. So both of these variable is very important in this topic. Okay, now I will explain this amplitude shift keying, ASK. So what is ASK? ASK is a digital modulation technique that transmits the data by varying the amplitude of a carrier signal. So a digital signal with the binary numbers 0 and 1 is used to switch the carrier amplitude low and high respectively. So as you can see in this figure, the upper one is the carrier signal, and it multiplies with the information signal, the middle one here. So this one here, it shows it is a high amplitude, and 0 shows it is a low amplitude. and these two times together it will form an SK, and the waveform is like this. Okay, frequency shift keying FSK. So what is that? It is a digital modulation technique used to send digital data across a carrier wave by altering the frequency of the carrier signal. So let's take an example over here. So in this figure, there is two example of ASK, ASK1 and ASK2. So as mentioned earlier, the upper one is the carrier signal, and the middle one here is the information signal 101, and the another one is 010. So by multiplying these two, it will form a ASK1 and ASK2. So ASK1 plus ASK2, it will form FSK, and the waveform will be like this. Okay, phase shift key, PSK, what is that? It is a digital modulation technique where the carrier signal phase shift from 0 degree to 180, or from negative 90 degree to 90 relative to the reference phase. So let's see an example over here. As mentioned earlier, the upper one is the carrier signal, so it multiplies with this information signal 10110, so it will form PSK. So you must be wondering why this is PSK, not ASK. So as you can see here, whenever there is a logic change from 1 to 0 or 0 to 1, the small part changes over here is a phase shift. So this is phase shift key, PSK. Okay, in PSK we have generation and receiver. So to generate a PSK signal, a level converter is used to change a unipolar input signal into a bipolar one. So the bipolar input signal and the carrier signal are then combined into a PSK signal by the balance modulator. And for PSK receiver, to modulate or receive PSK signal, the PSK signal is multiplied by a carrier signal and passes through a band pass filter. And the detector will detect the signal and transform it back into its original form. So you can see the example over here in this figure, PSK generation and PSK receiver. Okay, in PSK we have generation and receiver. So to generate a PSK signal, a level converter is used to change multi-level shift keying. There is a symbol that can represent more than one bit. So what is symbol? The symbol is the final signal representation, including amplitude, frequency, and phase, prior to transmission via a physical medium. And 2 power of n symbols are required for n bits. For example, to show 2 power of 2, which is 4, symbols are shown in 4 combination, which is 00, 01, 10, 11 that uses 2 bits. This is applicable to SK, SSK, and PSK. It is also proven that QPSK is very useful. And for quadrature phase shift keying, which is QPSK as mentioned earlier, so there's just one symbol represents 2 bits. For example, combination of 2 bits, which is 00, 01, 10, 11, can be represented by 4 symbols, and the phase will be different from 0 to 360 degrees. And take note that for binary PSK, the phase changes from 0 to 180 degrees. So this table shows the mapping of QPSK using gray code.
Hi, so I'll be talking about Project Kuiper by Amazon for the recent advancement in communication field part. So Project Kuiper is actually an initiative by Amazon to provide global internet access. It aims to deliver high-speed and affordable broadband to underserved and remote areas. This project also involves launching a constellation of low Earth orbit LEO satellites. It seeks to improve internet connectivity in areas with limited or no traditional infrastructure. Their goal is also to bridge the digital divide and improve connectivity for millions of people. The impacts and benefits of Project Kuiper to the society is that it gives us an improved global connectivity. As it provides high-speed internet access to remote and underserved areas, it also reduces the inequality by offering affordable internet access to communities. For the healthcare advancement, it also supports telemedicine, allowing patients in remote areas to access healthcare services so that they don't need to travel long distances for it. For the education access, it also enhances access to online learning resources, enabling students in isolated regions to pursue their education without any limitations. For the economic growth, it also facilitates e-commerce, digital entrepreneurship, and also remote work opportunities, fostering economic development in regions with limited connectivity. Next, for the misconceptions on Project Kuiper, the health concerns would be that satellites emit harmful radiation waves to people. This is false as they only uses low-frequency radio waves such as the ones we use in our cell phones and also Wi-Fi routers. These are actually non-ionizing and it cannot cause damage to living tissues. Next, for the safety risk and space debris, it is said that large number of satellites would cause space debris and collision in orbits. But Amazon uses controlled deorbiting where it minimizes the risk of space debris and also satellite collisions. For the legal issues, many people think that Project Kuiper operates without sufficient regulation, but actually Amazon has already secured regulatory approval as stated in the slide. Last but not least, for the cultural concerns, many thought that this project could replace local traditions with Western-centric ones. So as a resolution, this issue, Amazon can come up with a plan to collaborate with local creators for content diversity. That's all from us. Thank you.